So let's look at how a thread actually runs and its life cycle. So a thread basically starts by some process calling the thread creation. That process can be init, which is basically the first process that is running on Linux, but it can be another process. So let's say a web server, for example, where you're serving multiple requests and you basically call thread create to create a new request handler to handle a new request that is coming to your web server. And once the thread is created, the thread doesn't run directly. It goes into basically a data structure that stores all threads that are ready to run, but that have not been allocated CPU time yet, or basically compute time yet. So the thread starts in the ready state and is stored in this data structure. Now, the reason that you do that is that, well, you might not want the thread to run right away. You might want it to sleep for a while or something. But then you schedule the thread to run, and that can be basically because it's the scheduler decides that it's time for this thread to run, and it starts running, doing whatever it is supposed to do. But then a thread that is running has one of three options. It either exits, and that basically occurs when you have it basically occurs when you have the computer, the CPU finishing what it is supposed to do, and the process ending, basically the thread ending. And if it's the first time that the thread runs on the CPU, it's very atypical to basically go from running to exit right away, because otherwise it's a really short. It would be a really short running thread, because the CPU time that gets allocated per thread is not that much. I mean, it can be in the order of milliseconds or even microseconds sometimes. A thread that is running might basically, after doing some stuff, need to fetch data from memory or need to fetch data from hard disk, and that basically means that it needs some I/O. Or it can be just waiting for me to move my mouse cursor. And in that case, the thread basically calls thread wait, and the thread wait puts the thread into some waiting state and basically waiting for something to happen. And that thing is typically some I/O that you need, or some, you send the data to a co-processor, for example, if you have two processors, and you're waiting for the answer, or something on that order. Once that event happens, it can be also that you're waiting for communication from another thread, right, running on a different processor, or waiting for some result of some computation that another thread will produce, or waiting for a network event, for example. So in general, you stay in the waiting state until that event happens. So suppose that you have that thread as listening, waiting for a network packet to come, basically. Then once a network packet comes, then the thread basically uses thread join and goes to the ready state again. Okay, and then from the ready it gets scheduled again. So this path is basically governed. This path happens when the thread needs to wait for something. Okay, but the scheduler might also suspend the thread by calling thread yield and put the thread from running state to ready state, while the thread having everything it needs to run, but, well, there's not enough processor time for it, or it just got deprioritized for something, you got an interrupt or something. And this is basically the thread life cycle. When there are no threads in the system, there is an idle thread. And that's basically a thread that gets scheduled when there is absolutely nothing on your computer to do. And that is, you can, in theory, implement a zero-threaded kernel, but it's not very easy because of the way the hardware works. A processor is basically an electronic device with electronic gates, And as an electronic device with electronic gates, it needs to voltage and clock to be up. And they do that one way to basically ensure that you're not losing voltage, or and you're not basically going into a state where your clock is mismatched with the actual clock or something, is to basically not allow the computer to do nothing. You basically put an idle thread, and using that idle thread you will have one thread per processor, one idle thread per processor. In very modern architectures, what happens is when you have an idle thread is that you put also the processor on a low power sleep mode when the idle thread runs. And that basically makes the processor go into, reduce the amount of power that is used and so on. Then the idle thread is the lowest priority thread that you can ever have, because you do not want the idle thread, for example, to be scheduled every now and then. The processor, if the processor has 1,000 other actual threads to run, why should it go and run an idle thread that basically does nothing, right? So the idle thread has the lowest priority ever in your whole system. And in doing that, you basically make sure that your processor is, the electronics are up and running in a more easy way. But also you make sure that the idle thread does not interfere with the normal operation of your processor, or of your scheduling.